Hello, I'm Mr. Brundage, Aarmourtherm Foundation. I'm the CEO and owner of Aarmourtherm Foundation. You'll see us on aarmourtherm.net. I'm here today with John and Robert Gira, and they are TPO manufacturers or coatings for rubber roof coatings and different coatings that involve rubber. So these TPOs are thermoplastic aromatic olefins. So these aromatic olefins are very, very flammable. We're going to try to make them not flammable. So we're going to do a test today. I'll be questioned on it, but this test is strictly for the engineers so that they understand the order in which these materials fall under. They fall under several different products and not to be confused one with the other. And each one of the products will be shown in the material data safety sheets and as SDS safety data sheets. So you can go to the aarmourtherm.net site and you can see the quantitative data and the placement of the products. Thank you. Now this is a prototypical test for a TPO coating, a thermoplastic or thermosetting olefin, which is basically a rubber compound. This material here is foam. You recognize that as foam. Would you like to feel that? That foam is the foam that was at the Great White Fire when all those people died. So it's the same kind of foam. Those people didn't die specifically from fire. What they died from was a release of cyanide that comes out of this foam. It's released in an isoether or a gas of toxic materials. So this TPO coating, or this coating that I make, which is compound 5, not to be confused with 1, 2, 3, or 4. This is compound 5, and there are many other compounds.
What is the significance of using different compounds for different TPO?
The reason for the MSDS and SDS reports and the technical data under Fourier's law of heat transfer is to show the placement of the material for the specific job, because you can use some of them. They try to use 2F as a component for TPOs, or they'll try to use armor green or different materials which are not really suitable for that. That's a really low-end heat transfer material, 2F is, but it's only for construction. This in particular is for a polyurethane-based MTBE isocyanate. So this material holds cyanide. Now, it is extremely flammable, in which we'll test. So could you hand me my torch back there? Now we're going to test it with MAP gas. MAP gas is 5,300 degrees, and this is a turbo torch, so this is a very powerful torch. It can burn you from 18 inches away, so it's very powerful. But what we want to do is we're going to show the gaseous ethers or toxins that come off of this, and we'll put it out real fast, but we'll show you what it does. So now this stuff is very, very fusible. It'll melt in just really fast. So you get the camera on there. All right, now we're gonna hit it. Okay, now see, what we see is not only flames, but we see the melting isoethers. Okay, now put it out. All right, now this material is extremely flammable and extremely toxic. This is toxic material. This is cyanide gas in an MTBE base. So it's an isocyanatic hydrogen cyanide based in a methyl tertiary butyl ether. It smolders. It's a bad material. This material, if you're in an enclosed area like those people who are Great White, or those people probably in the crash of the Malaysian Airlines, they breathed the MTBE from the liner from the cargo space, which came into the plane, and most likely they died of MTBE or cyanide poisoning. They didn't even have time to call on their phone. We're going to test this against this foam because we want to see if this TPO will withstand the heat of this. We're not going to test it at 8 inches away, but we're going to test this at 4 inches away.
Now, is this a coating that is formulated with one of your compounds?
Yes, this
what
is.
What number compound is on this?
Now, this formulation for the rubber compounds, the TPOs, basically anything that is a rubber substrate of methyl tertiary butyl ether, a butyl or a butyl nitrate, then this material will slow down the absorption of heat. So we're going to test it now, and we're just going to see how long we can go before this foam melts behind it, because if it transfers heat, this will melt not only to catch on fire. So let's see what it'll do. Okay, this is a highly tenacious material. This is not a standard 2F product. This is a different product. Each product we make has a different formulation. Do we have any off-gassing that you can see?
No, absolutely not. Very clean.
We have no flexing. If we do, I'm going to get it right in my hand. So this is definitely a different material than the 2F. This is a 5F material that goes way up the line. Now this is leased to the Department of Defense for specific purposes, which I cannot comment on. So they are under lease. And by the way, our leases are all limited. They're all specifically designed for engineers and different companies that want a non-heat transferable substance that won't transfer heat. And the materials were designed specifically with a limited lease. We give no other leases but limited. So as you can see, we have no smoldering, we have no off-gassing, we have no smell, no odor,
nope.
We have no toxicity, we have completely eliminated the transfer of heat into the foam. So that means that the people that fly airplanes and have seats and the people that have furniture, the people that have rubber in cars and tires and things like that, we can lower the temperature of those materials drastically.
Make it a little safer.
And make it safer for people so they don't die. Now, we're going to go further here because we've created an intumescent coating. So we're going to take off that coating and see if it got to the back side to the rubber, and to see if there's anything we put there, which we didn't. So we'll take one of our utility poles. By the way, this is an excellent coating, highly unscarifiable, sequestering material. It sequesters toxins, so it'd be perfect for telephone poles or utility poles. So look, it got through to there, but it looks like it didn't get completely through. So there, we're down to the second coat. There's the second coat. So it looks like it didn't make it.
Absolutely.
This is a good material. This is compound number 5. You'll see the SDS and the MSDS reports and all of the mathematic quantitative data for heat transference under 4Ayer's law. It'll be based under the math created by geoscience, Dr. Popendik, Dr. Yambra, Dr. Tremillo, and Dr. Bond at Geoscience in San Diego. Anybody who wants to contact me over this particular TPO coating, which is good for any roof coating, any car, tires, whatever, body parts, undercoatings, airplane coatings, whatever, you know, for extremely scarifiable, low VOC, self-sequestering of toxins. You call me. My name will be in the caption.